Hello, hello. Yeah, sorry about that. My electricity went off. Okay, so where were we? Yeah, we were trying to fix the shape of this guy, right? So, man of. Hmm. So what actually happens? We would multiply the last dimension of this guy, which is embedding shape, which is 64, right? With the first one of k, right? So this is embedding size, and this should also be embedding size, right? So mm, my base size is 16. This is the context length. I mean, I'll start this thing by putting embedding factor 32, and we'll see with this. Okay, I'm running everything. My audio is fine, right? Okay. Uh-huh. So what do we have here? Oh man, same data type but got long integer and float. I mean that's because of okay. Why is that happening? That would probably wait. Uh, that would probably eventually stop, would it? So we have head. Uh, the linear register buffer. Where is it's a buffer use? I have no idea. Probably will be used in the future. Oh yeah, yes. Booker. Okay. Uh, what should I do? I don't think I can test this thing. Man, it would have been so fun if I could just test this thing in parallel, but here we are. So we get the key. Also we need the query. So it's probably uh-huh. Alright. Now what is the equation for weight? I mean attention in transformers. Formula. I know the formula, but I just want to show it to you. Right. Q into K transpose. So, man, I kind of want to run this thing. It would be so fun if I could. Probably I can test with the test data, right? I can make a sample data. So H is head of 100 and H of torch dot random of 10 and a pattern track. Okay, I need 3. So what would the batch size have to be? 16? What is the time step? That is a context length. That would be 32. What would be the embedding C? So let that be 64 now. 64, I mean, let it be 32 now. My bad. Okay, something happened. I don't know what happened, but something actually happened. That's kind of cool, right? Let's put out equal to this, right? So we created key and query matrix. Now we have to matrix multiply. So let's say out equals k at the cube. That was wrong. Query multiplied by key. But I can't do that because 1600 and 1632. Oh, so even transpose doesn't work, right? So how do you do this? K dot transpose minus 2 minus 1. I don't know what that means. It just worked. Okay. What do you do? I mean, I can. It's better if I probably try. What? Where I go? We'll see. Okay. Okay. Let's break this down. I mean, print k dot shape and q dot shape. Uh huh. Oh. Hmm. So whatever this thing dot shape, it becomes 1632, and then probably this 16 stayed, and the other thing matrix multiplied, right? Yeah, things like that can happen. Okay, that makes sense. Did it make perfect sense? No. Okay, now what is your shape? 16, 32, 32, that makes sense. Now what should I do? I should divide this by the dimension root of dk. Okay. Out equals out divided by cross power of dk. What is the embedding dimension of k? Embedding size, right? And I want to raise it to minus. That's the case. I also have to multiply minus. See a square root, right? Is it? Okay. Minus 2. No. Power is an invalid combination. Got intent, but expected one of tensor input, tensor exponent, tensor out. I don't know. Then how do you do it? Yeah, sure. Into C raised, okay. Into embedding size raised to root, right, minus 0.5. Literally the same thing. Cool. Now we calculate the weight. Now you take the softmax and then matrix multiplied with the V. But before all that, GPT architecture. Okay. Out equals f dot softmax out that one. Class doesn't have an attribute softmax. Well, what do you mean? What asset and then dot function. Okay. Implement the dimension choice for softmax as multiplicator. Tends to bound in the okay. So all I want to do is from the shape. Same shape. In fact, I think I want to visualize it too. These are the probabilities. I'll do this here too. Yeah. The big number minus 2 became 0.05, which makes sense, right? That is a very reasonable answer. This probably gets very big. Not really. Anyways, all right, all right. Now we continue with out equals out at V. That don't work. V. P and Q. Okay. Self dot V of X. All right. Return out. And let's have you. Let's comment you and you. And then both of you. And then you. Yes. Right. The problem with this card is there is no what is it called, masking of the future tokens, because during inference it doesn't matter provided it is trained correctly, and during training it will not train correctly. So I need to implement masking here. How can I do masking? Well, basically makes a mask to fill several trill. I'll try. Come on, man. Explain how the masking is done. The masking mechanism in the code is used to implement a causal mask or auto-regressive masking that ensures that the self-potential calculation cannot look ahead. The key part is the process is the shared-drill tensor, which is created using task.drill. What does this create? This creates a lower triangular matrix. Okay. Oh, so the future tokens will not. Okay. Now we matrix multiply, right? For int out, we have this. In fact, we are also putting out that child. Fixing 32, 32. I mean, out equals multiply out by this line. No, matrix cannot be multiplied. 5 by 32 and 5 by 5. This is a 32 by 32. So we have this matrix, and when I multiply, it becomes, well, the same thing. Why that? Why doesn't this work? The issue is that you are handling masking part. So I have to create a B. Okay. That is nothing. Oh, I have the element wise attention score. Okay, so does this thing work? Okay. Okay, boy. How about now? To update the card still have few issues. You are still multiply the attention score by the lower Lagrange matrix, which will not work as expected. The reason it doesn't work, the out has the shape BTT where we okay. Is the shape been changed? No, right? It shouldn't be. Then this wouldn't work. Yeah. Okay. So how is this done here? You do masked fill. Uh, okay. Come on, man. I mean, I think I'm going to stop him for now. Wait. No. Why is it not working here? I have no idea. Mm. Okay. I think my thing just works, right? The only thing I have to do right? This way, yes, it just works. The only thing I have to do is out this, what is it? Out dot mask the fill. Out equal to 0, comma, plot of minus infinity. Okay, this works. Cool. Oh, that's all I need. How about now? There's still a couple of issues. Why does this 32 come? The masking with there's a multiple extensions called by large Raman matrix. This is in there's a proper element as a potential multiple unit of a mask of attention. Mhm. Yeah, I don't even have to multiply actually. I just create a mask. Hmm. Okay. I think initially this thing works. Probably can be improved. No need for element wise multiplication here. Yeah, I think that'll do. We'll do dimension equals minus 1. Right? Really? Where is the minus infinity? Oh wait. Okay, we are multiply by v, right? Okay, all good. Rod 1. Right. I think I'm going to stop the stream now. Yeah, I have to go. So yeah, sorry that